Hi guys! Today's video is on the distributive property. So if you remember, in yesterday's video we learned a whole bunch of properties about addition and multiplication. Actually, I got those right here. We talked about the zero property, the identity property for addition and multiplication, the commutative property, and the associative property. Today we're learning another property, and it's called the distributive property. And this one is a really important property, and it's one you're actually going to use a lot in math. So it's something that's used all throughout algebra, which means you're going to use it this year and next year, 8th, 9th, 10th, all the way up through the rest of high school and college. You're going to be using this property. So it's really important that you learn this, because it'll make your life a whole lot easier if you can understand how to do this. So the distributive property, what it does is it connects multiplication with addition and subtraction. So that might sound a little bit confusing right now, but we'll see an example of it in just a minute. So that's what it's doing, is it's combining these two together. And to do that, we need a few pieces that we're going to look at. So again, these ones are review a term. Remember, it's a number, a variable, or both, and an expression. So again, looking back, got to go back a couple. Like right here, this is our variable, this is a constant, and together these are each a term. So that's one term, that's another term, and they make our expression. So those are what our terms are. Some of us are still confused on that, so it's just each piece of your expression. It's kind of like the words of your math sentence. A variable is the letter for an unknown value, so that's going to be something like our x. Remember, it can be any letter. Anytime we have a letter that's representing a number, it's called a variable. Equivalent expressions, we just learned that term yesterday. Equivalent expressions are same or equal expressions, so expressions that are the same or equal. Multiplication, we know what multiplication is, but today we're going to look at multiplication with a number outside of parentheses or a number next to a variable. So let's start looking at this and see what's happening. So our example for today, right here I have multiplication inside of my parentheses, and I have this number out in front, number outside of parentheses, that is multiplying by what's inside. So to do this, we want this 6 to multiply by both terms that are in there. We can't multiply it to just one, that wouldn't be fair. It's got to multiply to both the x and the 5. So normally you're used to simplifying what's inside the parentheses first and then multiplying, but that's hard to do when we don't know what x is. Okay, and we also will see examples today of when a number is next to a variable and how that's multiplying. So that would be an example like 3x. That really means 3 times x, and remember, 3 is our coefficient, x is our variable, and together they make a term. Okay, so what I want to do is, I need to grab a whiteboard. I forgot to grab that. Actually, I can do it right here. Okay. Right here on the back of this, I want to kind of demonstrate the idea that we're doing today by drawing an area map. So if I have a rectangle, and you can write this down or you can just watch for a minute, you're going to be writing your own in a minute. If I have a rectangle, I know that to find my area, I can do length times width. So let's say that my length of this rectangle is 4 and my width is 3. I know that I can multiply these together and my area would equal 3 times 4. I'm going to slide that over a little bit so you can see it. My area would equal 3 times 4, or my area would equal 12 once I multiply those together. And we can see this by drawing little boxes. I can divide this into 3 this way, because I've got 1, 2, 3 units. Remember, my individual pieces are units. And I can divide this guy into 4 pieces. So now I have a box that's 3 by 4, just like I said it was going to be. And if I counted up all of these boxes, I would have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units, 12 little squares, so my area is 12, just like I thought. But let's say, instead of writing 4, maybe I've got 2 smaller boxes that I'm squishing together side by side. Let's say for this rectangle, and hopefully my marker doesn't die on me here. Let's say for this rectangle, this length is still 3, but let's say I did squish 2 boxes together like this, and they're both a length of 2 on here. Okay, so I see this is still a total length of 4, just like I had before, but I'm writing it as 2 plus 2. Let's see how we could do this. I know that for this box I would still have 3, and it'd be divided in half into 2, so I would have 3 times 2 for my area, which is going to be 6. 1, 2, 3, 4, 5, 6. That marker's dying. On this side I would do the same thing. Still 3, still 2, 1, 2, 3, 4, 5, 6, and I'm just using an X just as a different symbol to represent that. So again, I would have 3 times 2, which is 6. And I could add those together, adding the areas, we've seen that in our bell work. Adding the areas together gives me 12, which is what I expected. Both of these would have an area of 12. Okay, so what I really did here is I have 2 plus 2, and I multiplied the 3 by that 2, and I multiplied it by that 2 as well, which gave me 6 plus 6, which equals 12. This is the concept that we're going to follow to do our distributive property. I distributed this 3 to each of the terms, or to each of the 2's. So, if I look back over here, I now have these as my length and my width. So let's see how we can multiply those. So the first thing we want to do is we want to draw a rectangle. Okay, so I'm going to draw my rectangle, and I'm going to draw it kind of small so I've got plenty of space right here. Let's say that this side here is a length of 6, and this one is x plus 5. And it's okay that we don't know what x plus 5 is, because we don't know what value is being plugged in for x. We can still use this. So I'm just going to draw a line cutting it in half. This doesn't mean that these two are equal, it's just how we're going to represent this idea. So we are going to set up the problem. We're going to write the terms and divide our rectangle into separate boxes. That's what we just did here. So we wrote our terms and we divided this into 2 pieces. Okay, next I want to share or distribute each term into the boxes. So I'm going to do my 6, and it's got to go into this box and into this box, because that's what this side and this side are represented by. And then I'm going to bring my x down in here, and I'm going to bring my 5 down in here. And these are multiplying together, so I could have just written that as a 6x, or I can put a dot in between to remind me to multiply, whichever works best for you. So I've got these in here, and I've got these in here, and these are multiplying together because it's like I'm finding the area of each of these pieces. So now I want to multiply the terms in each of the boxes. So I've got them set up to multiply. Now I want to actually multiply them, and then I'm going to write the answers underneath. So 6 times x just comes out as 6x. 6 times 5 is 30. And then I'm going to put the operation sign between each term. And they started out with a plus right there. So I'm going to write a plus down here. And this would be my final answer. It's distributed. So what I did is I multiplied the 6 by each of these pieces. I had 6 times x, which gave me 6x. And I had 6 times 5, which gave me 30, and I kept the operation right in between. Okay, let's look at a few more examples before I let you try this on your own. So I'm going to start by drawing my rectangle, and you can draw these pretty small. That'll be fine. I've got to divide it. I'm going to write my terms, so I've got an A on this side, and then I have a B plus C up here on top. So I'm always writing this number out in front, the littler one, on the side, and then what's inside my parentheses is going across the top. Okay, now I've got to share or distribute. That's where distributive property comes from, is we're distributing, sharing things out. I've got to put my A in each of my boxes, And then I've got to bring the term on top down. So I have AB and AC. So these are multiplying again. Once I multiply, I have AB down here, AC down here, and they had a plus as their operation. So I'm going to put a plus down in the answer, and that one's done. Okay, let's try this one. This one's got all numbers, so technically I could simplify first, but I want you to practice the distributive property, so we're going to leave this unsimplified for a minute. Okay, so for my rectangle, I'm going to have 3, and I have 6 minus 4 on top, so my 3 goes into each of my boxes, and the one on top comes down, so I'm going to have 3 times 6 right there, 3 times 4 right here. It's okay if you leave this minus sign off of the 4 for right now, because we're going to add it back in a minute. 3 times 6 is 18, 3 times 4 is 12, and since I started out with a subtraction, I'm going to leave that minus sign right there in the middle, and this would be my answer. And since we're distributing, you can leave it just like that. Yes, technically it would simplify and equal 6. And we could use that to double check our work, because if we double checked this, we know that 6 minus 4 is 2, and 3 times 2 also equals 6. So I know that these areas are the same, so I know I distributed correctly. This is kind of a good way to practice if you want to practice distributing and make sure you're getting it right, is to just use examples that have all numbers. Okay, these ones, we're back to ones of the variables, so let's see how this goes. So, drawing my rectangle, I get a 12 over here, I get an R plus S on top. My 12 gets shared, multiplies by the R, multiplies by the S, so I get 12R plus 12S as my answer right there. Draw a little box around it so I know I'm done. Okay, last one. So I'm drawing my rectangle, dividing it, 2 goes over here, R minus 6 up on top. 2 gets shared, times the R, times the 6. 2 times R is just 2R, because that still really means 2 times R. We just write them squished together so we don't have our dot there. 2 times 6 is 12, and I put a little minus sign in between. That's all there is to this. Hopefully this is making sense. If not, please ask me questions in class and we'll go over it. Okay, it's your turn to pause and try. Bye!